Ever wondered how machine learning models avoid overfitting? Pondered how they maintain balance between bias and variance? There's a term for this: lasso regularization. It's a technique that keeps models nimble and accurate, even when handling vast amounts of data. So, what exactly is lasso regularization? It stands for least absolute shrinkage and selection operator. This somewhat verbose name gives a hint about its function. It shrinks the data, and it selects the most important features all in one neat package. Step 1 in understanding lasso regularization involves recognizing its purpose. It's a method used to prevent overfitting. Overfitting occurs when a model becomes too complex, trying to capture every tiny detail in the data. While this might seem like a good idea, it actually leads to poor predictions on new unseen data. Lasso regularization helps to prevent this by adding a penalty term to the loss function. This penalty term is the key to lasso regularization. It's a simple idea, but one with profound implications. The penalty term is essentially the absolute value of the coefficients of the model. This penalty discourages large coefficients because they increase the loss function. As a result, the model becomes less complex and less prone to overfitting. Now, step 2 involves understanding how lasso selects features. It does this by driving the coefficients of less important features to 0. This effectively removes these features from the model, simplifying it further. This feature selection aspect is unique to Lasso and is a major advantage over other regularization methods. But how does Lasso decide which features to shrink to 0? This is where the least absolute part comes in. Lasso minimizes the absolute value of the coefficients, thereby favoring smaller ones. This means that features with larger coefficients, which are often less important, get shrunk to 0. To summarize, lasso regularization is a two-pronged approach to preventing overfitting. First, it adds a penalty term to the loss function that discourages large coefficients. Second, it shrinks the coefficients of less important features to 0, effectively removing them from the model. What sets Lasso apart is its ability to perform feature selection, something not all regularization methods can do. By favoring smaller coefficients, it ensures that only the most important features remain in the model. This makes the model simpler, more interpretable, and less prone to overfitting. In conclusion, lasso regularization is a powerful tool in the machine learning toolbox. It helps to balance bias and variance, making models more accurate and reliable. So, the next time you're designing a machine learning model and are concerned about overfitting, remember lasso regularization. It might just be the solution you're looking for.